Hello everyone. So today we will be covering section 1.2 and 1.3. So fair warning, it might be a little bit of a doozy because there's a lot of information I'll be throwing at you. But have no fear. If after this video, if you have any more questions, we can talk about it more on the lecture on Friday. Right, so let's start with section 1.2, which is applications with linear and rational equations. Right, over here we have the problem solving strategy, and here's the 5 steps. We'll go over this when we do our first example. Right, so before we go through our example, I want to talk about this simple interest formula. I is equal to P times R times T. I is considered the simple interest value. P is the principal amount, so the amount initially invested or borrowed. R is the annual interest rate, and T is the number of years of a loan or investment. Right? So let's go look at our example. Our example is Kent invested a total of $8,000. He invested part of the money for 2 years in a stock fund that earned the equivalent of 6.5% simple interest. He put the remaining money in an 18-month certificate of deposit, or CD, that earned 2.5% simple interest. If the total interest from both investments was $855, determine the amount invested in each account. Alright, so with this example, what I did, I just did step 1. Alright, so let me put example right here. Alright, step 1. Step 1 is just read it carefully. So don't worry about underlining or trying to figure out what's in, or just don't worry about getting everything the first time you read it. The first time is just just kind of getting a general idea of what you're getting yourself into. Alright? So, and you should determine the what the question is asking, right, from the first time you read it. Right? So step 2, it says make an appropriate figure table. So technically there should be like a step 1 part B. Then what I normally like to do is get all of this information, right, and just underline what we know. Right? So we know Kent invested a total of $8,000. Right? He invested part of the money, so part of the money, for 2 years in a stock fund. Whoops, and it earned 6.5% simple interest. Right? He put the remaining money, in an 18-month CD, and it earned 2.5% interest. If the total interest, from both investments was $855. And our question here is our goal is to determine the amount invested in each account. Sorry, I tried to underline as straight as possible. I wish there was a highlighter here. I think it would have been better, but it's fine. We'll make do with what we have. Right? So now that I have all this information, what is the question asking? Our question is wondering what is the amount invested in each account, right? And what are each accounts? We have a CD and we have a stock fund. Right? So we're going to assign variables to unknown quantities. Right? So first things first, we know the biggest thing, it says Kent invested a total of $8,000, and we know that he has 2 accounts. He invested in a stock fund and a CD. So I'm just going to say X. If you look in the book, they let X be the stock fund, but I want to let X equal the CD, right? Just to show you guys that as long as your logic still makes sense, like everything is still lines up, you'll get the same answer no matter what approach you do. Just make sure your logic makes sense. Right? So in this case, I'm going to let my X equal the CD. Right? So let's make a table. Right? So we know we're given the principal So I'm going to label this CD. SF is for stock fund, and then this is total. Right. Let me, as you can see, I don't know how to draw straight lines, so I'm going to use this. Alrighty. So we know the interest principal, and then yeah, because we know CD, the amount invested in the CD plus the amount invested in the stock fund is $8,000. Right? We also know the interest. Right? We know the interest made from the CD plus the interest made in the stock fund. We know that is $855. Right? So let's focus on here. So we let X equal to CD, right? Before I continue, you do have to tell me what your variable is. Alright, if you just put X, I'm going to say what's X. Alright, so make it very clear on what you're labeling your value. Alright, so what about stock fund? Instead of assigning another variable, right, let's just continue using the one that we have. So how do we find the stock fund? So we know that he invested into a CD, right? But the total amount that he invested was $8,000. So what are you going to do? You're going to take that $8,000 and you're going to subtract it from the amount he invested in the CD. Right. For you, it might make more sense to read the other example in the book because it did say he invested part of the money in the stock fund. So if you called that Y, and he said he invested the rest into the CD, so it would have been 8,000 minus Y. Right, that might make, when you're reading it, it might make more sense, but like I said, I'm going to do it this way so you can just see, you'll get the same answer. Right, so what about this part? Right, so that is where our equation comes in handy. I is equal to PRT. Right? Because we know from all this information that they gave us, we know the arbitrary principal amount, so which is up here, right? We also know the rate, that the simple interest, and we also know the amount of time that it was in there. So we can just use that. So over here for the CD, we know it's going to be interest is equal to the principal, which is X in our case, and then the rate, so the rate was 2.5%, okay, but we want it in decimal form, so what are we going to do? We're just going to move the decimal place to the left 2 times, and we get 0.025, right? And then we have it's an 18-month certificate. But remember, for time, it is the number of years. So for 18 months, how many years is that? That is 1.5, right? Because there's 12 months in a year. So if we have 18, we know it's 12. We're left with 6. And 6 is half of 12, so 1.5. Right? So this is the interest for the CD. It's going to be X times 0.025 times 1.5, right? So what about the stock fund? The stock fund, we know the interest is 8,000 minus X, is equal to the principal, which is 8,000 minus X. The rate in this case is 6.5%, right? So again, when we're calculating this, we want this to be in decimal form, so this is going to be 0.065, right? And then it said that we invested it for 2 years, so we don't have to compute anything here, just got to put a 2, right? So now that we've put our table together, right, we want to write an equation that represents our verbal model, right, or create a formula. So if you look at the first one's not going to help us so much, okay? Because if you set the amount of CD plus the principal amount of the stock fund, okay, and you set that equal to the total, as you can see, these x's cancel each other out. Right, so you get 8,000 is equal to 8,000. The best thing over here is that you do get a check, like, did I compute this value correctly? Because it should equal, and these do equal. Alright, but this doesn't help us at all. So let's go back to the scratch board. So what else do we know? We know the interest. We know as if we add the interest of the CD plus the interest of the stock fund, we will get $855. Right, so we can, I'll write it in words first. So the interest, I'm going to put INT, interest from CD plus the interest from the stock fund, we know that is equal to the total interest. Right. So now let's put it all together. Over here, the interest from the CD, that is X times 0.025 times 1.5. Plus the interest from the stock fund, we know that is 8,000, minus X times 0.065 times 2. And we know when you add all of this up, we will get 855. Right? So this is the equation. So now we are going to solve it. Right? So this is just like anything. So this is still a linear problem. Right? So our goal is to solve for x. Right? Let me pull up a calculator because we're definitely going to need that. Right, so over here, the very first term, I have x times 0.025 times 1.5. I'm going to multiply the numbers. So 0.025 times 1, not plus. Right, that's oh my goodness. Put this over here real fast. Right, so this is 0.0375x, right? And over here, right, I'm first going to multiply the 0.065 and 2, right? And then we can distribute that in a little bit. Okay, so 2, we get 0.13. This is 8,000 minus x. Right? We have nothing to do on the right side. Right? So remember, our goal is to solve for x. So, but there's an x in this parenthesis. So what are we going to do? We're going to distribute this, right, to free that x. Right? So 0.0375 x. Right? For those of you that don't know, if it doesn't matter if you put a 0 here. Alright, these two still mean the same thing. Alright, I'm just a little lazy, so I'm not going to do that. Right. So 0.13 times 8,000, that is 1,040. Right, minus 0.13x. Again, we don't have to do anything on the right side. Right. Before we continue, I'm going to combine. So it's going to be 0.0375 minus 0.13. Right. That is going to be negative 0.0925 x plus 1,040 is equal to 855. Right. So over here, like I said, I usually like to keep the coefficient of my the coefficient to my x positive, but in this case, I'm just gonna leave it negative because it's less steps to move the constant over. Right? You can do a switchy switch if you want. It's up to you. You don't have to. All right. So 1,040 minus 855. All right. That is going to be what, 195? 185. Oh, and this is going to be negative because I subtracted 1,040. Right, so the bigger number is 1,000 and it's attached to a negative. Right, so we're really close. Now we want the x to have a coefficient of 1, so we're going to divide both sides by negative 0.0925. And when we do that, get 185, whoops. Right, 185, I'm just going to divide it by 0.0925. I'm not going to deal with the negatives because I know a negative divided by a negative is a positive. Okay, and we'll get 2,000. Okay, so what does this mean? This means that the principal amount that he invested in the CD was $2,000. But before we say that this is our answer and before we find the amount he invested in the stock fund, let's make sure that this is correct. All right, so what am I going to do for the CD? We know the interest is equal to x times 0.025 times 1.5. In this case, we know x is 2,000. Right? And when we do that, so 2,000 times 0.025 times 1.5. Right, that's $75. Right. For the stock fund, okay, we know the stock fund, the interest is equal to 8,000 minus x, which is 2,000, okay, times 0.0625 times 2. Right, so this is 6,000 times 0.0625 times 2. Right, 2 times 6,000, that's 12,000, so I'm just going to go ahead and type that in, and then 0.0625, wait, oh, man, I made a mistake. Try to do this from memory, and that did not work. Okay, so let me fix that real fast. This is 0.065, this is 65. Right, and this is 780. Right, and so what are we going to do with these values? We know that the interest from the CD plus the interest of the stock fund is 855. So our question is 75 plus 780, is this equal to 855? Right, and guess what? It is. Right? So we know that this is correct, or that this holds. So because this holds, this means I'm going to write our answer over here so I don't have to use that much more notebook space. This means that the amount invested in the CD is $2,000, and then the stock fund is going to be $6,000, right? Because 8,000 minus 2,000 is 6,000, right? Make sure when you give me the answer, make sure you use the correct labels. In this case, it's just a dollar sign, right? And I really want to emphasize the dollar sign goes here. This is not correct, okay? No, it goes in the front, right? And as you can see from over on the right, this is the correct answer. Now let's talk about the D is equal to RT, which is called the uniform motion formula, right? So what is it? It is D is equal to RT. It means distance equals rate times time, where D is the distance traveled, R is the rate at which the object travels, and T is the amount of time an object travels at a particular rate. Right? So let's go ahead and do the example. So first things first, we're just going to read it. Right? Donna participated in a 41-mile biathlon that included running and bicycling. She spent an hour and 45 minutes on the bike and 45 minutes running. If her average speed on the bicycle was 12 miles per hour faster than her average speed running, find her average speed running and her average speed riding. Right? So, now let's underline what is useful. Right? She participated in a 41 biathlon. Right? So what does that mean? That means that she ran and she biked for 41 miles. Okay? She spent an hour and 45 minutes on the bike, 45 minutes running. Right? Her average speed on the bicycle was 12 miles per hour faster than her average speed running. Find her average speed running and her average speed riding. Right? And so our goal is to find these. Right? So first things first, let's what word am I thinking? Label a variable, right? So, reading this, so we know one thing that really caught my eye is that she said that her average speed on the bicycle was 12 miles per hour faster than her average speed running, right? So, what is that? That kind of tells me that I want X to be her average running speed. Right? So let's make a table real fast. Okay, so we're given, so we have running and we have her bike. Okay, and we're given distance, rate, and time. Give me 1 second to draw these out. Ooh, not straight, it's fine. Okay, as long as they're partitioned. Okay, so what do we know? We know that her average speed, okay, so what is the average speed? The average speed is your rate. Okay, so for running, her rate is just X, and for her bicycling, it is going to be 12 plus X. You can also write X plus 12. It doesn't matter. Addition is commutative. Right? What else do we know? We also know that her time. So she spent an hour and 45 minutes on the bike. Right? And before you put 1.45, that's wrong. All right? So time is in base 60, and the numbers we use are in base 10. If you want me to talk about that more, you can mention it in class. But essentially, let's think about this clock. Right? And we know this is 12, or like 0 minutes, 15 minutes, 30, and 45. Right? So when you do an hour and 45 minutes, what is that? That is 3/4. Right? So 3/4, so you can put, so it's 1 3/4. I don't like mixed fractions. So you can either say this is 7/4, or you can just put 1.75. Right? And this is minutes. Or no, this would be hours. Right? And then for 45 minutes running, I'm going to say 0.75 hours. Right? But keep in mind, what is distance? We know that distance is equal to rate times time. So for here, we know distance, since it's rate times time, for running it's going to be 0.75x. And over here, it is going to be 1.75 times 12 plus x. Right? And yeah. So we almost used all of this, but what else do we know? We know that she the total distance that she traveled for everything is 41 miles. So what does that tell us? We know that we know that if we add the distance, so the running distance plus bike distance, this is the total distance. Okay, so what can I do? For my running distance, I know that is 0.75x plus 1.75 times 12 plus x, and this is equal to 41 miles. Right? So this is our equation, so let's go ahead and solve it. So I have 0.75x, I don't need to simplify this. Over here, I'm going to distribute because there's an x in here, right? So I got to free it. So again, let's get a calculator. So 1.75 times 12 is 21 plus 1.75x. Okay. Okay, we got to combine like terms. 0.75 plus 1.75, that is 2.5. Right, and then I'm going to subtract 21 over to both sides. When I do that, I get 20. Right, and then x. So to get a coefficient of 1, I'm going to divide both sides by 2.5. So 20 divided by 2.5, that is 8. Right. So what does that mean? This means that her rate, okay, so we have miles and we have hours. Okay, so what does the rate mean? It's going to be miles per hour. Right? And then for the bicycling, what is her rate? It's going to be 8 plus 12, which is 20. Right. So average running speed is 8 miles per hour, and then average cycling speed is 20 miles per hour. Alright, and this concludes section 1.2, and we'll go over these two problems in class on Friday. Before we go on to section 1.3, I did forget to mention, how do we know if this is correct? So what are you going to do? You're going to take your x, and you're going to see, does it satisfy this equation? Right, so let's go ahead. I'll do this on this side. So we're letting x equal 8. Okay, so we have 0.75 times 8 plus 1.75 and then 12 plus 8. Is this equal to 41? Alright, so 0.75 times 8, 6. And then we already know 12 plus 8 is 20, so 20 times 1.75, that's 35. Is this equal to 41? Right, 41 is equal to 41. So yes, these are the correct values, right? And this is how you check it. Right. Now let's talk about section 1.3. Section 1.3 is all about complex numbers, right? So first, before we talk about a complex number, let's talk about the imaginary number. The imaginary number, which is represented by the letter I, and is defined as I squared, which is equal to -1, or it is the square root of -1 and it's equal to I. Right. So as a consequence, if b is a positive real number, then the square root of negative b is equal to I times the square root of b. Right. So let's do some examples. Okay, so we have this square root of negative 2. So in this case, we want to keep in mind, we know that the square root of negative b is equal to I times the square root of b. So in this case, b is equal to 2. So what is this? This is I times the square root of 2. Right, and this is the solution. The next one, we have the square root. I'll do a different color. Let's have the square root of negative 64. Right, so in this case, what is b? b is 64. Right, so if I rewrite this, this is I times the square root of 64. Right, but in this case, so over here on top, I couldn't reduce the square root of 2 anymore. But over here, what is the square root of 64? The square root of 64 is 8, because 8 times 8 is 64. Right, so our answer is 8i. Okay. The next problem we're going to do, and I'm going to do it on the right here, I have the square root of negative 24. So again, let's take out that negative. So to do that, this is going to be I times the square root of 24. Alright, and we have to see, can 24 be simplified? Alright, so the best way to do this, so you should be comfortable with your perfect square. So what's a perfect square? It's like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc. Right? We're not going to look at 1 squared because 1 times anything is itself. Like, it doesn't help us at all. Alright, so I'm going to start with 2 squared, which is 4, and then 9, 16, 25, and then you can keep going down. However, this is 24, so I don't have to go any higher. So what I'm going to do, or what I usually suggest for people who aren't as comfortable with reducing radicals yet, is you look at the highest, the first perfect square that is smaller than 24. Right? So it's not going to be 25 because 25 is greater than 24, but then we look at 16. Right? And I'm going to ask myself, does 16 go into 24 perfectly? Right? It doesn't, because if I divide 24 and 16, I get a remainder of 8. Right? And then I ask myself about 9. And again, that's not true because we get a remainder of 6. So it's going to be 2, remainder 6. Right? But what about 4? Right? 4 does go into 24 perfectly because 6 times 4 is 24. Right? So let's rewrite this. So this is I, and then if I rewrite this, this is 6 times 4. Right? So one thing, probably should have talked about this before, but it's fine. It says, recall from previous math courses the following rules about radicals. We're going to assume the roots represent real numbers. So the first one I really want to look at is the square root of a times the square root of b is equal to the square root of a times b. It's also true for the square root of a times b is equal to the square root of a times the square root of b. So what am I going to do? I'm going to take, 6 times square root of 4. Right? So square root of 6, there's nothing. But square root of 4 is 2, because 2 times 2 is 4. Right? And again, tell people before they continue, we have to make sure about 6. However, the smallest one is 4, and 4 doesn't go into 6 perfectly. So this is our answer. Alright? So, I already talked about the multiplication square root property, so let's talk about the division one. The division one is the square root of a divided by the square root of b. That is equal to the square root of a divided by b. And again, it also goes the other way. So the square root of a over b is equal to the square root of a over square root of b. Right? The rules are true for positive real numbers a and b, so if a and b are negative, we deal with the negatives first. So what does that mean? Let's look at the following examples. Okay, so we're given the square root of negative 16 times the square root of negative 25, right? Actually, before I go, I'm going to talk about with ones with smaller numbers. So square root of 2 times the square root of negative 4. This, right, is not, you cannot do negative 2 times negative 4, which you will say will be square root of 8. Right? This, no. Okay, when I say deal with the negatives first, this has precedence over it. So what this actually equals, right, I'd have to do I square root of 2 times I square root of 4. Right, so then we'll get I squared, and then 2 times 4, which is 8. So this is going to be negative square root of 8. Okay, keep in mind, so this can actually be reduced. This would be negative 2 square root of 2. Right, but we'll talk about simplifying radicals more. So, but as you can see, you get 2 different answers, right? So keep in mind when you're thinking about PEMDAS, right, you're going to do this first, right? So let's go back to our example. So the square root of negative 16 times the square root of negative 25, we're going to deal with our negatives first, so I'm going to pull out that I first. We can get our i's together, so this is going to be I times I, which is I squared. We also know what the square root of 16 is. The square root of 16 is 4, because 4 times 4 is 16. Okay, or you can think 4 squared is equal to 16. Right, for 25, our question is, so what squared is equal to 25? And in that case, it's going to be 5, because 5 squared is 25. Okay, let's simplify. So we know I squared, remember from our definition, I squared is equal to negative 1. So this is negative 1 times 4 times 5. Okay, so this is negative 20. Now let's do an example where we're dividing. So we're given the square root of negative 75 divided by the square root of negative 3. Okay, so first let's deal with our negatives. So this becomes this. Oops. Right. Normally what I tell students is before like you multiply, divide, or anything, I would reduce first. Right, but sometimes it is easier to do the operation before you simplify. Right? So I would just kind of look ahead and see if it will make your situation better. In this case, if I reduce the 75, it's going to be a lot more work, as opposed to if I just set these equal, or just put them all under one radical. And because 75 divided by 3, that's 25, which automatically gives me a perfect square. Right? So let's go ahead. So I'm going to do a couple of steps. So these i's, it's I over I. All right, so these make 1. Right, so that's 1. And then over here, I'm going to use that property. So I'm going to get 75 divided by 3. When I do that, I get the square root of 25. Right, and what squared is equal to 25? 5 squared is equal to 25. Right, so this is our answer. Right, we'll do a couple more problems in class on Friday. Right, so now that we know about imaginary numbers, let's talk about complex numbers. Complex numbers are written in the form a plus bi. So what's the definition? The definition is it is the set of numbers that includes the real and imaginary numbers, and that is called the set of complex numbers. So given real numbers a and b, a number written in the form a plus bi is called a complex number, where the value a is called the real part and the value b is called the imaginary part. Right? So, like for example, 8 is the imaginary part. Okay? 2 times the square root of 6, that is the imaginary part. Right? Anything, the number that is attached to I is considered the imaginary part. Right? So, let's talk about a plus bi. So if b is equal to 0, then a plus bi, that just equals the number a. the real number a. So what does that mean? That means all real numbers are also complex numbers. All right, I'll let that soak in for you. So, but if b does not equal 0 and a equals 0, then a plus bi just equals bi. So, what does that mean? That means that bi is a pure imaginary number. So, these two up here, so the a and I and the 2I times the square root of 6, these are called pure imaginary. Right? So the standard form of a complex number is in the form a plus bi. Right? So sometimes we will write a minus bi instead of a plus a negative b times I. Right? And another thing, all right, I really want to emphasize this. Sometimes, and we should say most of the time, we write, instead of 1 plus square root of 5 times I, we'll write it as 1 plus I times the square root of 5. It's to emphasize that I is not under the radical, right? Because sometimes people overshoot the radical, so they'll say radical 6, and then they'll have their I here. My question is the I inside or outside? Right, so in order to make it more clear, we just put I in front of it. All right, so let's do some examples. Alrighty, so example 1, we are given 3 minus the square root of negative 100. Right, and remember, we want to write the result in the form of a plus bi. So over here, okay, so minus, and then we have a negative here, so I have to pull out the I. Right, and then I'm going to ask myself, what squared is equal to 100? Right, and if you said 10, then you are correct, because 10 squared is equal to 100. Right, and this is our answer, and this is in the form a plus bi already, so we don't have to do anything. The second example, we're given 2 plus 7i over 5. Right, when you look at this, yeah, there's nothing to reduce. However, what do we want? We want to write the result in the form a plus bi. This is not. This is just one clump, right? So what are we going to do? We're going to separate it. So for this 5, okay, it's like, okay, so you know when we have a over c plus b over c, then this can be a plus b over c. Right? So again, this is the exact same, but what we're doing is we're going to read it from right to left. So we have a plus b over c. So I can rewrite this as 2 over 5 plus 7 over 5i. Alright, and I'm just going to pull out the I in the front so we can clearly see what b is. Right, and this is our answer. Right. Lastly, we have negative 6 plus the square root of negative 18 all over 9. Right? So, first, let's solve. So over here, as we can see, we have that negative under the radical, so let's take that out. Right, and we have the square root of 18. Right, I'm asking myself, I'm going through these squares, and when I do that, I get the perfect square 9 goes in here perfectly. Alright, so this is negative 6 plus I, and then square root of 9 times 2, all over 9. Okay, negative 6. Alright, this is, I'm just going to put it on the side, alright, but this looks like this. Alright, so this is going to be plus 3i times the square root of 2, all over 9. Okay. I also noticed all three terms have a 3 in common, so first what I'm going to do is I'm going to take out a 3. Okay, when I do that, I get negative 2 plus I squared of 2. Okay, all over, and then 9 can be rewritten as 3 times 3. Okay, these 3's, they can reduce to 1. Okay, when I do that, I'm left with negative 2 plus I squared of 2 all over 3. Right. Again, we want to be in the form a plus bi, so we're going to go take one more step, and this is going to be negative 2 over 3 plus the square root of 2 over 3i. Right, and that's our solution. Right, and then we'll talk about this in class. We'll talk about this problem in class on Friday. Right? So now what we're going to do is we're going to talk about operations on complex numbers. So first, let's draw our attention to this. So we know I to the first power, that's just I. And we also know by the definition I squared is equal to negative 1. Okay, but what about I to the third power? I to the third power can be rewritten as I squared plus I, because remember the exponent rules, like x to the a times x to the b. This is x to the a plus b. Right? As long as they have the same base, we can add, and they're multiplied, we can add the exponents. Right? So, and yeah. Okay, when we do that, we get negative 1 times I, so we get negative I. And then I to the fourth, it can be rewritten as I squared times I squared. And so that's negative 1 times negative 1, which is positive 1. Right? But now let's look at 5 through 8. Right? 5 through 8, we all take I to the fourth out, and we know that I to the fourth is 1. Okay, and we're left with I squared, I to the first, I squared, I cubed, and I fourth. And as you can see, it's just I, negative 1, negative I, and 1. So this is okay. I'll let you know, I'm left-handed, and I'm using my mouse for this with my right hand, and it's not going very well. Oh, that wasn't too bad. Right, but as you can see, there's a pattern of I, negative 1, negative I, 1. Alright, so what does that mean? That means, how do I explain it? If you take the power of the I, you can see if it is divisible by 4. If it is divisible by 4, you can just say it's 1. Right? And then after that, so if there's a remainder of 1, then you know that it's going to be I. A remainder of 2 is negative 1. Remainder of 3 is negative I. Right? And that's just, if you want to memorize it or anything, I'll show you guys 2 ways of doing it. Right? So I to the 52. Okay, I to the 52, so 52, let's look at it. 52, if we divide it by 4, we get 13. Okay, so since this is divisible by 4, this is just 1. Right, but let's say you forgot that rule. One thing that we'll always know that should just be drilled in your brain is that I squared is equal to negative 1. Right, everything else, this whole I cubed, I to the fourth, that's just kind of extra knowledge, right? Well, not the I, but the I cubed and the I to the fourth, right? But this should be drilled in your head. So how else can I do this? If I do I squared, okay, another exponent rule is x to the a to the b is equal to the x times a, x to the a times b. Right? So in this case, 52, I want a to be 2. So how do I find b? I'm just going to divide it by 2. Right? And when I do that, I get 26. Yep. So what does this equal? This equals negative 1 to the 26th. Right? And when there's an even power, okay, this is just going to be positive 1. Because let's think about it. If we think about negative 1 squared, that is 1. If we think of negative 1 to the fourth, that is also 1, because 1 times negative 1 times negative 1 times negative 1 times negative 1. That is positive 1. Because this is positive 1. This is positive 1. Positive 1 times positive 1 is positive 1. Right, that's a mouthful. But even, like, if you don't believe me, check it. Like, you can even put in the calculator negative 1 to the 20th power. I promised you, it'll be positive 1. Right? So, as you can see, we get the same answer. Right? But what about I to the 27th? I to the 27th, the first method, okay, if we divide it by 4, so 27 divided by 4, we'll get 6. Okay, when we do that, 24, we get a remainder of 3. So what does this equal? This equals I to the 24th. I got that from doing 4 times 6, and then I cubed. Okay, since this is divisible by 4, I know this is 1, and then I cubed, and we've established I cubed is negative 1, or negative I. So 1 times negative I, this is negative I. Right? The other way, okay, so over here I just divided it by 2 automatically because it's an even number, but when it's an odd number, we just have to break off an I. So I'm going to do I to the 26 times I. Okay, because 26 plus 1 is 27, so I didn't change anything. Okay, and when I do that, this is going to be I squared. Okay, what times, or 2 times what is equal to 26? That's 13. This is I. Okay, so this is negative 1 to the 13th I. Alright, so I told you guys when you multiply, if any negative number, so not just negative 1, any negative number to any even power is positive. But when you take a negative number and you multiply it by an odd power, it's always going to be negative. Like you can even test negative 1 cubed, negative 1 to the 5th. You can even test negative 1 to the 21st. I'll let you guys do that if you don't believe me, but I promise you, you'll get negative 1. Right? This is negative 1 times I. So what do you get? You get negative I. Right? So as you can see, any method works. Well, not any method, but I'm saying these two methods, whichever one you pick works. Right? I'm just going to do number 3. Number 4, I already gave you the answer, is negative 1. I'll let you guys test that out, but I know I'm probably going over time. I kind of forgot when I started recording, but I feel like it's been a while. So I'm going to try to hurry it up. So let's do one more example for simplifying i's, and then we'll continue, or we'll go on. So for this one, we have I to the negative 19th. Right? So this is a little odd because we've only been dealing with positive exponents. Right? But this is still the same thing. Alright? So what am I going to do? I'm going to this is going to be for method 2. I guess it could be for the first method as well. So what I'm going to do is I'm just going to make this even. Alright, so what am I going to do? My goal is to make I negative 20. Okay, because that's the negative next even one. And I'm just going to do I. Alright, so let's test it. Negative 20 plus 1, that is negative 19. Alright, so this is the exact same as this. Alright, so what we're going to do now is, if you want to do the 4, that's fine. Alright, but I'll go ahead and just do the squared. So if I have I squared, 2 times what is equal to negative 20? That's negative 10. Okay, so then we'll get negative 1 to the negative 10th I. Alright, what does the negative 10 mean? The negative 10 just means I'm going to bring this down. So this is going to be negative 1 to the 10th. Right? However, it doesn't matter because this is just a negative 1. Whoops, this is negative 10. So tiny. Let me rewrite this. So it's going to be 1 over 1 to the 10th. Negative 1 to the 10th. Okay, but anyways, this is still going to be 1 over 1. This is a positive exponent. Okay, so it's just 1, I, so this is just I. Right, if you do the fourth one, then you can just say this is I to the 4th to negative 5th. Right, and this is 1 to the negative 5th, but 1 to any power is 1. Right, so this is I. Right, so as you can see, either method works. Right, so you can do that on your own if you like, but we'll talk about these other problems in class on Friday. Right, so let's truck on. Right, so now now that we know how to simplify i's, like large powers of i's, let's talk about the 4 operations. So we're going to do add and subtracting. We're just going to combine those. So how do we add and subtract complex numbers? What you're going to do is you're going to add or subtract their real parts, and we're going to add or subtract their imaginary parts. So for example, we're given 6 minus 10i plus 8 plus 4i minus 2 plus 3i. Right? The very first step in this case is we want to get rid of our parentheses. So what we're going to do, we're going to distribute. But over here, the first 2 is just positive 1, so I can just drop it. Okay. But over here, we have to be really careful because there's a negative. So this is going to be negative 2 minus 3i. Okay. So now what I'm going to do, I'm going to gather all the real parts. Okay, so I'll just write it down so we can see it. Okay, and then we're going to gather all of the imaginary parts. Okay, so this is going to be negative 10 plus 4 minus 3i. Right, I just factor out the I because I is a common thing. Like if you distributed the I, you'll still get these 3 terms. Right? When we do that, so 6 plus 8 minus 2, that's 12. And then negative 10 plus 4 is negative 6. Negative 6 minus 3, that is negative 9. Okay, so negative 9i. Right, and that's our answer. So adding, subtracting complex numbers, not too bad. Just remember, it's pretty much like as if I were x. So if I did like 6 minus 10x, right? How would you add these? You would just combine the like terms, right? So now let's talk about multiplying complex numbers. Right? So when you multiply complex numbers, we're going to use distribution that's similar to multiplying polynomials. Right? So the first example, we have negative 1/2 I times 12 minus 6i. Alright, so what am I going to do? I'm going to take this negative 1/2 I and I'm going to distribute this. And when I do that, I get negative 12i over 2. And then this is going to be negative times a negative is a positive. So this is going to be 6i times I over 2. Okay, how about, let's do this. 6i squared over 2. Okay, now let's simplify. So negative 12i divided by 2, right, that's going to be negative 6i. Okay, and then 6i squared divided by 2, that is going to be 3 times negative 1. Right, I squared is negative 1, 6 divided by 2 is 3. So when I do that, I get negative 6i minus 3, right? But remember, we want the form to be a plus bi, right? So we just want the real part first, so we have to use commutative property and switch these around. Right? And this is our solution. Right? So for number 2, okay, I'll put it over here. Number 2, we want to multiply negative 3 plus 2i and then 4 minus 5i. Right, so how do we do this? We're going to use the FOIL method. Right, so FOIL or distribution. So I'll show you two ways. Right, the FOIL method, I'll do it second. So what you can do for the distribution is you can act like this is just one giant thing, right? You can just act like this is a box. Right, so what are we going to do? We're going to take this entire thing and we're just going to distribute this. And when we do that, we get negative 3 plus 2i times 4. Hold on. Yeah. Plus negative 3 plus 2i times negative 5i. Right, and then you're going to distribute these. So I get negative 12 plus 8i. And then over here, okay, this is positive 1, so we don't really have to worry about this side, but we'll have to still distribute the negative 5i. So we get plus 15i minus 10i squared. Okay, when we do that, I squared, that's negative 1. Negative 1 times negative 10 is positive 10. Positive 10 plus, minus 12, that's negative 2, and this becomes 23i. Right? So that's if you want to do like the actual distribution method. But foiling, it just kind of, because I know some people get kind of confused with foiling, so I just wanted to show that method. Okay. You can also have put these in the front, so you could have done like 4, negative 3 plus 2i, minus 5i, negative 3 plus 2i. Right, it doesn't matter. Multiplication is just commutative. Right, well, let's do the FOIL method. The FOIL method is just going to be negative 3 times 4, which is negative 12. Negative 3 times negative 5i, that's plus 15i. 2i times 4 is 8i. And then 2 times negative 5i, that is negative 10i squared. Right, so a really good rule of thumb is you just take this first term right here and you just distribute it as many terms as the next part has, and then you take the second part and then you just restart it. Right, so you don't really have to memorize what FOIL means. Just stay in order. Right, so again, so this is the exact same, and you're going to get negative 2 plus 23i. Right, one big difference between foiling with real numbers and foiling with imaginary numbers is when you do this, right, when you FOIL with imaginary numbers, you're always going to be left with two terms. Always. Right? At most two terms. Right? You can still have one term. It just depends. Right? But yeah, so if you have 3 terms, 4 terms, that means you have to simplify more. All right? So that's just the biggest thing to remember. Right. So with multiplying, we also have special cases in multiplying. Right? And so for multiplication, we have the perfect square trinomial, which is a plus or minus b quantity squared, and that is equal to a squared plus or minus 2ab plus b squared. We also have the difference of squares, which is a plus b times the quantity a minus b, and this equals to a squared minus b squared. Alright, if you just FOIL it out, that's what you'll get. So these properties hold with multiplying complex numbers, but we have to remember to deal with the I. So if we have a plus or minus bi quantity squared, you get a squared plus or minus 2abi minus b squared. But if we want to keep it with the in the form a plus bi, like the real and the imaginary part, it would be a squared minus b squared plus or minus 2abi. And then for a plus bi times a minus bi, we get a squared minus b squared. Right, and that's a little peculiar, so let's talk about it. So I have a plus bi, and I have a minus bi. Right, so let's FOIL. So I have a times a, which is a squared, a times negative bi, which is negative abi. We have bia, which we can just say plus abi, and then bi times a negative bi. So I'm just going to put plus bi times negative bi. Right, so this is a squared. These cancel, right? That's plus 0. And then bi times negative bi. So that's negative b squared times I squared. But what is I squared? I squared is negative 1. Right? So negative b squared times negative 1, that is positive b squared. Right? And that's how we get that. Okay? You don't have to memorize these, but I promise you, if you learn these formulas, it'll make your life so much easier instead of having to FOIL everything all the time. All right? So let's do an example. Okay, our example says multiply negative 5 by its complex conjugate and write the result in the form of a plus bi. So, question for you, what is a complex conjugate? Complex conjugate, so if I'm given a plus bi, the complex conjugate, I'm just going to say conj, is going to be a minus bi. It is the opposite of your imaginary number, right? So a minus bi, it'll be a plus bi. Right? So a conjugate, it just changes the sign of the imaginary number. Right? And that's usually why we keep it in a plus bi instead of like bi plus a. Right? Because then this will be negative bi plus a. Right? But it's just easier to remember this one. Okay. So, first, what is the square root of negative 5? So the square root of negative 5 is I, the square root of 5. Right? So this is positive. Right? So what would the conjugate be? The conjugate is just the opposite. The opposite is negative I square root of 5. Okay? So if I take I square root of 5 and then I multiply it by its complex conjugate, which is negative I squared of 5. What do I get? I times negative I is negative I squared. Square root of 5 times square root of 5, that is 5. Okay, because, let's see. This is the square root of 5 times 5. Okay, you could say 25, or you can say 5 squared. This is 5. Right? Or say 25. It doesn't matter. Okay, but what is I squared? I squared is negative 1, so this is just negative 1. Okay, if you're wondering why didn't I do negative I squared, this is not the same as saying this. Okay, the squared is attached to the I, but over here on the left, the squared is attached to the negative I, right, when there's parentheses. Okay, so negative 1 times negative 1 times 5, that is positive 5. Right, and that's what you get when you multiply the square root of negative 5 by its complex conjugate. Right? Another example, we're going to multiply 7 minus 2i quantity squared. Right? Big thing. Okay? This absolutely does not equal 49 plus 4i squared. Right? That's a big no-no. Okay? If we have time in class, I will explain why more, but essentially, if you do this, because when you square something, you're getting the area of a square, and if you just multiply the ends, you're missing a whole chunk of your square. Right? But if you do this, oh my gosh, I will cry. Okay? And we don't want that to happen. So, one way, so if you do the perfect square trinomial, what do we know? We know that A is equal to 7 and B is equal to 2. Right? You can say negative 2 if you just want to deal with the positives, but if you know that there's a negative, then you should know that it'll just be negative down here. Okay, so what is this? This is going to be 49 minus 4 plus or minus 7, or not plus or minus, geez. Minus 7, or 2 times 7 times 2i. Okay, so this is going to be 45. Okay, negative 2 times 7 times 2 is negative 28i. Right? See, it's really fast if you know the formula. But if not, one thing to prevent you from, doing this junk, what you can do is squared. So if I say x squared, what is that? That can also be written as x times x. So just do 7 minus 2i. Right, and you can FOIL it that way. Right? It'll just be a lot more steps as opposed to if you did it this way. Okay? But if you're more comfortable that way, that's fine. Right? Lastly, right, we have to talk about dividing complex numbers. You'd think I know where this line is by now. Alrighty, complex numbers, or dividing complex numbers. So to divide a complex number, we're going to multiply the numerator and the denominator by the conjugate of the imaginary number in the denominator. Right? So what do I mean? Let's do an example. Okay. For number 1, I have negative 2 plus I all over 5i. Right? So we don't want a complex number in the denominator. So what are we going to do? We're going to take this whole fraction and we're going to modify a little bit by multiplying it by 1. But in this case, we're going to do the conjugate, which is negative 5i. Okay? So keep in mind, if you just put negative 5i, you are wrong, even if you do multiply, because you wrote it wrong. Alright, because we're multiplying by 1, so it's not changing anything. Like when you do 1/2 times 3 over 3, that's 3/6. Is this any different? No, it's still 1/2. Right, just rewritten differently. So let's do this. So I'm going to distribute this. So negative 2 times negative 5i, that is positive 10i. And then negative 5i times negative 5i, so it's going to be negative 5 times negative 1, that's positive 5. Okay, and then 5i times negative 5i, right? So 5 times negative 5 is negative 25. I squared is negative 1, so negative 1 times negative 25, that's positive 25. Okay, these all have 5 in common, so let's factor a 5 out. So I get 2i plus 1, right? 25 can be rewritten as 5 times 5, so these 5s can cancel, so we're left with, okay, I guess we can just write 2i plus 1 over 5, that's fine. Right? But keep in mind, what do we want? We want it in the form of a plus bi. So this could be 1 over 5 plus 2 over 5i. Okay? Up here, you could have totally rewrote it as 1 plus 2i over 5. Right? Last example of the day. Right? Thanks for holding in, guys. You've been troopers. Alrighty, so the second one is going to be a little more complicated. I have 8 plus 2i over 3 minus 5i. Okay, so first things first, we want to multiply this, the numerator and the denominator, by the conjugate, the complex conjugate, which is 3 plus 5i over 3 plus 5i. Okay, so when we do this, okay, this, keep in mind, it is our difference of squares for the complex conjugate numbers. So what is that? It's going to be a squared plus b squared. A is 3, b is 5. So this is going to be 9 plus 25. Okay, and over here we're just going to FOIL. So we have 24 plus 40i plus 6i plus 10i squared. So I squared, remember that's negative 1, so this becomes a negative 10. So 24 minus 10 is 14. 40i plus 6i is 46i. And 9 plus 25 is 34. Okay, they all have a 2 in common, so let's factor that out. Okay, and this becomes 2 times 17. Oops. Alright, so this becomes 1. So then this is 7 plus 23i over 17. But what is our instructions? Our instructions say to write it as a plus bi. So this is 7 over 17 plus 23 over 17. Alrighty guys, that is it for today. I told you it was a doozy, right? But thanks for watching, and I will see you guys on Friday. Bye!